Ladies and gentlemen, please say hello to ESA. Come on out.
Ground control to Major Tom. You've really made the grade. And the papers want to know whose shirts you wear. Now it's time to lead the capsule if you dare.
Wow. Hello, FedCon. Thank you for having us. Thank you for having us, and thank you for staying this late for the bitter end of the panels to hear us chat. I hope you got some good questions for us. Before we get started, though, I just want to say thank you to all of you because, I mean, we love our jobs, but sometimes we have meetings and spreadsheets like everybody else. And when we come here and talk to you on the stand or going around, we realize that it's actually quite exciting what we do. So we're very grateful to all of you for that. Tonight we're going to answer your questions. There's microphones dotted around. I think you know the drill by now. But to start off, we're just going to introduce ourselves. So my name is Thomas. I work on our Sentinel-1 mission in Darmstadt, Germany. I fly the spacecraft, dodging space junk and keeping the satellite alive. My spacecraft does Earth observation. So we look down on our planet and provide free and open data to everybody to help our own spaceship here, which is the only one we've got at the moment.
Yeah, I'm Andrea Boyd. I work at the European Astronaut Center, quite close to here, next to the Flughafen in Köln-Bonn. I am the Deputy of Astronaut Operations for ESA, so Alexander Gerst and I basically run the astronaut program of ESA, and with my other hat, I'm Eurocom, so I'm the voice of Earth that you hear talking to the astronauts on the space station and interfacing with the flight control team on Earth.
Hello, my name is Csilla Orgel, and I'm a planetary scientist. I'm working on Mars and Moon missions, robotic exploration missions, such as the ExoMars Rosalind Franklin rover. And what I'm looking at is the landing area. So anything landing site related comes to me.
Hello, everyone. Hello, everyone. My name's Nick Champion. I am 26 years old. I'm from the UK, and half a year ago I was a student. I have started a graduate job in Darmstadt, Germany, and I work with the ground segment. So this is the way that the commands can be sent up to the satellites that we have, and how we get all the data down.
Hello, my name is Jana, and I believe you remember me as the problem solver of the group. The last time we spoke, I was in charge of approximately 10 missions, and I was kind of dealing with anything that could possibly go wrong. Now, I have moved slightly in my job. I have 15 missions. I think I probably forget half of them if I try to name them. But I only take care of the ground segment now, so if anything goes wrong up there, it's actually blissfully not my problem for once.
So my name is Armel. I've been flying spacecraft for 20 years this year. Yeah, I know. I'm flying currently the ExoMars TGO mission, which is mostly taking care of the relay data between the NASA rovers which are on ground and the Earth. And just to quote one single number, we are handling approximately 60% of the data, so we are very proud about that.
Okay then, thank you very much. Now I think the spotlight of destiny will appear. Oh yes, hello.
Okay, hello. I'm a physics teacher, and I'm always wondering, how do we get all the data from Mars to the Earth? So is there like a satellite system around Mars, And what happens when Mars is on the other side of the sun, so when we can't see Mars?
Okay, so we use radio wave to communicate bits of data. The closer we are to the Earth, the faster we can go. The maximum bitrate on TGO is 2.5 megabits per second. It's not much when you think about the internet, but...
Is it directly from the probes on Mars surface?
This is directly from the probe's high-gain antenna to the ground stations on the Earth. Then the further away we go, the further the distance between the Earth and Mars, the slower the communication goes because the signal power gets smaller and you want to be sure that you get a maximum of data. When we get very close to the sun, even before we pass behind the disk of the sun, we get problems with the sun corona that is interacting with our radio waves. So first we drastically diminish the bitrate to the point that we cannot even really downlink any science anymore. And then when it goes really too bad, we just close the shop and go on holiday for 3 weeks.
Good for you. Thank you.
Hello, my name is Peter. I'm very interested in exploring the Mars. I'm interested what would you people say? They said exploring of Mars is wasting of money, and which benefits we people have here on Earth on exploring other planets, and how likely is it to send astronauts during the next 15 years to Mars?
So, as I may have mentioned, I'm the least experienced here, but I'll have a go at the first part of the question. Well, there are two answers to this. Firstly, there are many more direct applications that come from space exploration. A lot of ESA's, I mean, this is not specific to Mars, but a lot of ESA's focus is at monitoring trace gases in the atmosphere of Earth, monitoring crops, all sorts of important Earth observation things. But when you go into these difficult environments that demand really tight restrictions on how you operate, it presents a lot of challenges that then make the development of new technologies happen. This happened early in the space race with the Apollo program encouraging the early development of computers. It happened to solar panels, to all sorts of things. But and so that is an unexpected byproduct that you can kind of get. But I'd argue that is almost irrelevant. The other side, so you can do science with a direction, or you could do science, and the other side is blue sky research, where you're doing it because you're curious about it, and sometimes really unexpected things come out of this stuff. There's also the case of it being inspiring, but someone else can take over for the rest.
Maybe I can have a go at the part about how it's good for mankind, or humankind, to be a little bit more correct. Something happened to Mars. Mars was once an Earth-like planet. We do have some idea what, but it would be really, really good to know exactly what the mechanisms were and possibly how much time we have.
And for sending humans to Mars, obviously because it's outside the magnetosphere, I mean, so is the moon, but then we have shorter missions and other methods of protection. So currently we're missing two things with sending humans to Mars that are still in the process of trying to be solved, and that's radiation protection and bone metabolism degradation as well. So regarding like bone remodeling and the countermeasures that we do, which work really well in low Earth orbit for shorter durations, but for longer durations it's difficult. So the bone metabolism and radiation protection, it needs to be solved before we can send humans to Mars as well.
Thank you.
And also, one last thing. I think it's also really important to remind people what the budget of ESA actually is. This is 10 euro per year per person. And with 10 euro per year per person, we go to Mars, we go to Jupiter, we observe the Earth, we have astronauts on board the ISS. Honestly, I am willing to not go to the cinema one night and do that instead. I think it's worth it.
Up the top. Oh, one of the up the tops.
Hi.
Hello.
Sorry.
Hello.
I know that there are always, in your drawer, you have a bunch of different scenarios, and you could start tomorrow to them. Let's say I want to send a human to Mars tomorrow. What would your plan A scenario look like? How many ships, how many crew?
I think first we would try to convince you not to. Not tomorrow.
I would add that it's certainly too early for Mars, perhaps a bit later. There are many problems, like you said, that need solving. The moon is a much more reasonable target. It's so much closer if something goes wrong. It's so much easier to get things there. And we're working on that currently. I mean, humans are working on that currently. I mean, the Artemis program that NASA has that is aiming to return people to the moon, hopefully to stay, that is something that Europe and other countries are also a part of. For example, the Orion capsule that will transport humans to the moon. The service module that is bolted onto the back of that provides the power and the stability, the engines, and other critical functions, that's made by Europe. And so we're having a part in returning people to the moon.
And honestly, that is how we get to Mars. We are following the plan on how to get to Mars. The service module that Nick mentioned was developed to take cargo to the space station. That proved the technology that we can now use to get us to the moon. So it's one step after another. Now we learn to live on the moon and work around the moon, and that's the next step on the journey out there. So you can say we're already following the plan.
Yeah, and it's just we're all actually working on the Gateway program, so having a station in lunar orbit, a Lagrange point, and the lunar surface moon base as a collaborative effort. But the moon is a lot easier because you can launch, anytime. It's about 3 days to get there. Mars, you can only launch once every 2 years, and you're looking at many months to get there. And again, we need to solve especially the radiation problem as well. We've got some new countermeasures exercise equipment that we're testing on the space station. Actually, another European moment, we had a bit of a competition, kind of, because we were developing, and NASA was developing, and ESA was developing, because we're trying to miniaturize the exercise equipment that we've got that we currently use on the space station, which is really essential if we want to bring astronauts back to Earth again. And we were both working on some new equipment that's much smaller, and the European one was better. So we are deploying that. We're deploying that on the space station soon, and we'll be testing that, and then that's really going to be ideal to go in these smaller capsules that we're sending out as well. So miniaturizing the exercise equipment with still being able to get the effectiveness is going to be one of the big things for the bone metabolism issue that I said as well. But yeah, Mars is difficult for humans, so we're realistically focusing on the LEO and the moon.
And I think it's worth adding again that, following on from what you said, the International Space Station is currently a wonderful testbed for the human aspect of human exploration. A lot of the main challenges come from human biology in this environment, and this is how we're researching it and building up to traveling further.
Brilliant, thank you. So,
Thank you very
where
much.
will the spotlight move next? Aha, hello.
Hopefully it stays now. I'm Peter. Thanks for bringing science to our fiction. I might repeat myself, but I cannot be repeating it often enough. Thank you for being here, guys. I would...
I would like to thank you for assimilating me earlier.
You're most welcome, anytime again. I would like to address my question into the direction of Cologne and the Astronaut Center. I know the schedule is pretty tight, but how are the chances? We just recruited a new bunch of astronauts in training. How are the chances that one or two of them, or maybe even two of our ESA ISS commanders might show up at FedCon maybe someday? Please? Pretty please?
Yeah. Well, yeah, Samantha and Alex were unable to this year, so we got the two-dimensional versions of both of them at our stand, so please come and take selfies with them tomorrow. The others, actually, do you know what? The new class of astronauts, their training is really crazy right now, but I did actually, because I had lunch with them a few days ago, and two of them were quite upset that they didn't have time to come to FedCon, so they asked me to remind them for next year. It's already on certain new astronauts' radar.
Thank you.
Good grief, that's bright. Hello, I'm just going to preface my question very shortly, if I may. I'm studying to be a librarian, and for my university I'm working on a project, I want to work on a project if everything works out, where I want to essentially talk about libraries and how we deal with knowledge in science fiction, and what it means for our future. And therefore my question, what kind of science fiction books do you read, both for leisure or books you think are science is good? Because before I can write anything, I need to read a lot of books.
I think we can each take this quickly, one person at a time. So I'll start. For me, I really love The Martian. It's way up there, partly because it's so close to reality and it makes me believe I can be like that at work. I don't think I am. I mostly turn things off and on again, but that's why I love it.
Power cycle.
Power cycle is the insider term, yeah.
I really like Neil Stephenson. When 7 Eves came out, like several NASA flight controllers and myself all started kind of reading at the same time and then like commenting to each other on our private chat group. And I really enjoy his books.
It's a tough question, but I think I also like The Martian, so it was very realistic.
We have a Martian-heavy panel.
Yeah, I mean, I'm a bit biased, right? So, and I also enjoy Carl Sagan's Contact. It's also my favorite film. And I enjoy watching Star Trek, Stargate, Sliders, all that. So sometimes when I'm too tired in the evening and after a tough day, I just like to watch television.
Well, the others have stolen some of my answers already. With The Martian, of course, we're a bit predisposed to that, but Andy Weir, the author of The Martian, if you've read it and if you like it, I would highly recommend, above all else, check out the latest book. I'm not being paid. It's Project Hail Mary, and I encourage you to go into it knowing nothing at all. It's crazy and wonderful, my favorite book. But I would add that I also like Contact by Carl Sagan and the Culture series by Ian M. Banks. A number of others. I'm happy to chat about it later. Thank you.
Well, being penultimate in this row here, I'm also met with the difficulty of already having everything taken from me. Unfortunately for everyone else, I have the advantage of coming from the East. So as somebody coming from the former East, I can wholeheartedly recommend the old Russian science fiction, like the Strugatsky brothers. Look it up. Their science fiction was bizarre to the Western eyes in some cases. Definitely very well-written time plots. totally worth reading. I hope you can find some good translations. But as no one mentioned it, and Armel still has a chance to hit that, did anyone mention Hitchhiker's Guide to the Galaxy? Sorry, Armel.
Okay, is it working? Yeah. This is a very, very easy answer. Clearly, up there at the top, I think first time I read it, I must have been 10, and by now I've read it, I can't even count. Dune. Clearly. There's another book I want to mention. Unfortunately, I do not know the name in English. In French, it's called Semailles Humaines, and I also cannot remember the author. I'm very sorry. And it's a story about exploring the universe, but basically it goes about not modifying the planet to fit the human, but modifying the human to fit the planet. And a big part of the plot is about these humans that got modified to be able to live in water. And there are these terrifying monsters that are attacking them. And at the end of the book, you realize that this ocean they're living in is just a puddle. And the puddle next to them are other humans where everything went wrong. And
Surface tension. Yeah. This short story is called Surface Tension.
Okay. Fantastic book. Read it. It's eye-opening.
Thank you, and I should say I literally have Dune in my backpack because that's what I'm reading right now.
Hello there. I'm a little bit nervous because
Me
my
too.
question has something to do with sex. Is it possible to get pregnant without gravity? Because I would volunteer for that. But I got married on May the 4th, and my wife is pregnant at home, so you need to wait for us.
So theoretically, yes. However, just to clear the record, no, we have not had sex in space. Nobody has. Yeah, everything still functions perfectly well. I feel like NASA will not tell you that because they have a bit more of a comms filter, but yeah, no, everything functions perfectly well in space, but we have not had procreation with any of our human missions. But yeah, we don't see any medical reason why it's not possible, because most of it's like menstruation and all of your normal functions are fine in space as well, because it's a what's the English word? Peristalsis. You know, like if you hang upside down, you can still eat something because it's muscular. It's the same thing. So it's yeah, it's functional in space in theory, but has not happened in practice.
Okay.
These are the questions we get when we do a late night panel.
Hello. My question
Nice
is to
t-shirt.
Nick. Oh, thank you. Sorry. Yeah, my question is to Nick. I'm very excited to have a young graduate trainee here today because I just started my engineering degree, my bachelor's, and I just wanted to ask when you started developing towards being a young graduate trainee, and what do you do as one?
Thank you for the question, and nice to see you.
Thank you.
So I studied physics. I then, briefly I'll mention the fact, so I come from England, I studied in Nottingham. After I graduated, I didn't know what to do. I will keep it short, don't worry. And I found applications very, very personally challenging for me. And I spent a year living at home with my parents, not really sure what to do, working a shop during the pandemic. That was a whole thing. I ended up moving to Germany to live in the same place as my girlfriend. And so I decided to start another master's in meteorology. That is not recommended. You don't need to do that at all. That was just me. But that did happen to give me the chance to apply again. And this time somehow I got in. They let me in, the fools. Have I answered the first part? Or,
yeah.
Okay. And as to what I do, I work, so some of us come from ESOC, Germany, the European Space Operations Center. A lot of what is done there is not about the space part, but about the ground part, the worldwide network of radio telescopes that are important for communicating and getting all the data down from different satellite missions. Most of that is radio. I work in a small team dealing with one unusual possible future technology, which is, instead of using radio, using a different wavelength of light, near visible infrared light, like actual space lasers to communicate between satellites and the ground. So as part of my job, I get to conduct tests with a small optical ground station on a mountaintop in Tenerife. Hopefully I'll visit one day. And yeah, it's interesting. I also respond to emails a lot, this kind of thing. But we can chat later, of course. And yeah, I would really love to say that I have been blown away by just the atmosphere of ESA, the diversity of the people and the wonderful international environment. You can go up to any of especially the young people, anyone there, and they'll be happy to talk about what they do. It's a really nice place. So, and you'll be surprised. Try and see if there's something for you.
Thank you so much.
So, in short, your job is to shoot space lasers.
That is right. I'm not sure if they actually go pew-pew, but I intend to find out.
Okay, well.
Yeah, good evening. First of all, just briefly to the question just now. We have so many men and women who've spent months on the ISS doing all kinds of experiments. Are we sure they didn't do one certain experiment?
I have had many beers with many astronauts, I'm quite sure.
Okay, but that was my main question is, obviously science fiction has learned a lot from science, from NASA, from ESA, etc. But are there anything specifically from science fiction which have got you guys thinking, oh, we haven't thought of that, that's a good idea? For example, sending Mark Watson to Mars with a packet of potatoes.
I mean, we do look to science fiction, and in fact, since the beginning of the space age, they've been coupled together. The geostationary orbits that we use, that was an Arthur C. Clarke concept. And that is a fundamental orbit. That's what all of the important spacecraft are in that provide you your TV, your weather, communications and everything. That was a sci-fi concept that became real. Now ESA is also looking into other sort of, what some people would say are crazy concepts, but if someone doesn't start somewhere, then we're never going to get there, right? So one of the programs we've just kicked off is called Solaris, which is looking into providing power from space. The idea that we could have vast solar collectors up in space and then beam that power back down as microwave beams to help solve the energy crisis we have here on Earth. But there are a number of these blue sky technologies that, yeah, that's exactly what ESA's here to do, is to start thinking about these things.
Yeah, and if you saw Aidan's talk with myself yesterday at the Astronaut Center, we also, actually speaking of students, we have a bit of an army of students that we basically let run loose in our laboratories with all of our resources, and they can come and pick our brains anytime, of the older engineers. And we let them kind of do whatever they like that's quite extreme, especially with lunar regolith. So we're letting them 3D print with lunar regolith, extract energy, maybe use it as a battery, the other way around, do kind of closed cycle plants and things like that, as well, and looking at just letting them really go loose with super futuristic ideas. And the 3D printing is effectively a form of replicators that we're going to be using on the moon by scooping up lunar soil and then being able to use it to construct things. And we've very successfully constructed quite a lot of things using lunar regolith as well. And that's a lot of that is really driven by younger minds and our students and our YGTs that we're having come through and letting them inject. We let them run with whatever crazy idea they want to come up with as part of their project, and we see where it goes.
Yeah, I've also heard that NASA is experimenting with warp drive. Are you familiar with that?
I'm not sure. I've heard they've done the maths, which, again, is a first step. I'm pretty sure it doesn't work with the technology we've got at the moment, but yeah, we try and start everywhere. I mean, I don't know, you know more, Nick?
I am not aware of any experiments like that. There are a number of physical technical papers, physics literature that talks about possibilities like that, but there's nothing practical at all in the foreseeable future, unfortunately. However, yeah, I actually just wanted to say it's even more a stronger concept than what you said about the geostationary orbits. I think I'm right in saying that the idea of space travel itself comes from science fiction and then became science fact. So it's a wonderful thing that happened.
I have a very good addition that probably did not strike everyone in the room. Just recently, there has been an experiment performed in a sort of mock asteroid diversion exercise, which pretty much copies one episode of TNG. I don't know if you noticed, right?
Yes, this was NASA's DART impact on a binary asteroid pair. So there was an asteroid near, in an Earth-like orbit, and it has a much smaller asteroid moon. They're Didymos and Dimorphos were the names. Don't ask me why. But they smashed a spacecraft intentionally into the smaller moon, and then were able to measure the change in the orbit of this moon. It became 30 minutes shorter in period. And yeah, and ESA's part in this, NASA did the hit, and ESA's part will be to send the HERA mission. One of my YGT friends, a recent graduate, is working on the HERA mission, and she is so excited. What this will do is go and, instead of just coming to this binary asteroid pair and smashing into it, it will go into orbit and carefully study what happens in this crazy experiment that NASA did. It will also learn a lot about other things, but in this asteroid redirection test, this, for the first time, humanity has demonstrated that it has the capability to deal with this existential threat from space. And it was actually more successful than people were expecting. There was more of a change in the orbit of the asteroid than we thought there would be, because of all the matter that was kicked out. A huge plume of this asteroid material redirected this. And so it's not exactly like the movie Armageddon, but it's... It's good to know that a few people are working on it, and they are thinking about this, because it sounds like science fiction, a terrible science fiction threat, but if one day there is a real threat, then we need to be able to deal with it.
Thank you, and keep up the good work.
Thank you.
I want to give you a point what the person has said with the pregnancy and reproduction in space. You may only need to write down 3 words in Google, human reproduction mass, and they will find that probably human reproduction. Was ist das denn jetzt hier? Wer soll denn jetzt hier? Was ist denn jetzt hier los?
Don't think we didn't quite get that.
Sorry, what was your question? Yeah, can you please repeat the question? We didn't hear.
Yes, I want to point you that with the pregnancy in space, that you must...
Please move closer to the microphone. Sorry.
Okay.
Let's move on.
See where the light moves next.
Hello.
Hi.
Since we are on a sci-fi convention, I would like to ask, of all the Star Trek franchises, Star Trek, Stargate, Star Wars, The Expanse, whatever, which one do you think is the most scientifically accurate, since science fact?
That's a good one. I think we're going to go around the room on this one, like around the panel on this one.
We could do a quick fire round. You start listing them and we whoop when we think we got it, okay? Would you like to go? Start listing and then we will respond when we hear the one we think, okay?
Okay, Star Trek, Stargate, Star Wars, The Expanse.
Yeah. There it is. Yeah. The Expanse actually used, in the opening sequence, we spotted they used one of the pictures from one of our Mars spacecraft. They put a Mars base on top of it, but I'm glad to see they're using our pictures to survey Mars.
Yeah. Well, sorry for that little game. Okay, what I particularly like about The Expanse is the way they accurately portray gravity and people sticking to the floor or floating. When the spacecraft accelerates, they feel a reaction force from the ground, and they are pushed into their chairs. And when the acceleration stops, and they're following the course they otherwise would because of gravity, then they float. Either if you're accelerating, or if you're standing on the surface of a planet and you're feeling gravity, either of those produce an equivalent effect. And otherwise, you and the spacecraft around you floats along together.
Thank you.
Have we answered?
Thank you.
Nice T-shirt.
Yeah, thanks. Thanks to you all to being here year after year after year. That's a nice add-on to the fiction we see here. A question, we learned a lot about the Mars surface, digging, handle that microphone, about digging, searching for life or traces of life, but knowing at some point humans might put their feet on the ground. When will we start searching for a nice place for habitat? Where are the rovers or the helicopters searching for an underground place? Are there plans?
Yeah, thank you for the question. So ESA has its first rover mission plan, which is called the Rosalind Franklin rover. We will be launching in 2028. And we would like to visit a place which is called Oxyaplanum on Mars. It's at the edge of Crisi, Planitia, and Arabia Terra. And we think that this area is one of the oldest terrains on Mars and might have, so those rocks which formed in that area formed through water activity. So the landing area has a rich geologic history, and also we found a specific type of mineral there, which is called like clay minerals. And there's a huge abundance of these minerals, and the rover has a drill. And the drill can go down to 2 meters. That will be the first ever drilling on Mars, and would sample the material from 2 meter depth. And we expect that this area is pristine, so it's protected from radiation, because the surface of Mars is highly radiated. So as we mentioned before, this problem has to be solved before humans go there. So, but then, yes, Rosalind Franklin will study this area, one of the oldest terrains on Mars.
And this is an incredible thing that NASA hasn't even done before. It's a really important question to see not just what's on the surface of Mars, but what is surviving the harsh radiation environment by being underneath the topsoil. And so I'm very excited to see what happens on this. But I believe the question was a little bit angled towards human exploration.
Exactly.
Right? So can you comment on what you think might happen afterwards? In the event that humans were to need to pick a landing site, what would be an interesting place to have our first missions?
So the humans should pick a landing site around the equatorial region in order to harvest energy with solar panels, and also that area is a little bit warmer than farther north or south towards the poles. So we would like to be a relatively ambient environment. So I think we go to the equator, and before that we will also send missions which will look for resources like water ice and iron and other metals, and to actually eventually build up a habitat on Mars and harbor a continuous presence of humans there.
Excellent. I think that's a great ending because our time is up, unfortunately. We have to say goodbye for now, but we're going to be upstairs on our stand all day tomorrow, so you can come and see us. And I just wanted to add, I mean, we do this, not just FedCon, but space exploration, and ESA does this for you, for Europeans, for humanity. But when we meet you and you show us how passionate you are, it really brings it home. So you have been an inspiration to us. Thank you very much. Come and see us. And if you don't mind, we're going to take a selfie with you all before we go off stage. Thank you.
Vielen Dank, dass ihr euch das Video angesehen habt. Wenn es euch gefallen hat, dann lasst einen Daumen nach oben da. Hier habt ihr nun verschiedene Auswahlmöglichkeiten. Ihr könnt oben links unseren Kanal abonnieren. Oben rechts geht es weiter zu tollen Videos von diesem Event. Unten rechts gelangt ihr zur Internetseite vom nächsten Event. Zu guter Letzt kann ich euch noch den Space Store empfehlen. Hier gibt es alles Mögliche an Fanartikeln zu euren Lieblingsserien und Filmen. Bis demnächst auf diesem Kanal.